Rainbows are beautiful, but how exactly do they form? And why is always the red color on the outside and the violet on the inside? And how far are these rainbows formed? These are some of the questions we'll try and answer in this video. So imagine I'm standing here, it's a beautiful day, and I want to see a rainbow. What do I need? Well, you might know we need sunlight. You don't see rainbows at night. So sunlight is important. Let's say here's our sunlight. We also need raindrops. It can be any drops, in fact, like it could be from the sprinklers or it can be from the fountain, but let's put raindrops. Now you might say, hey, raindrops are not round. Yeah, I've just considered them to be round for simplicity. You'll see it'll help us when it comes to drawing ray diagrams later. Okay, but how does raindrops and sunlight give me rainbows? We need one more thing to answer this question. We need to remember that rainbows are always formed on the opposite direction of the sun. If the sun is to the right of me, the rainbows will be on the left. If the sun is behind me, the rainbows will always be in front of me. So over here, the sun is behind me. So over here, I would see the rainbow in front of me. So with this info, that rainbows are always on the opposite direction of the sun, let's see if we can figure out how rainbows are formed, at least the basics. Well, here's how I like to think about it. Let's start from the rainbow. If I'm looking at the rainbow, I know that the light from the rainbow must be reaching my eyes. The red light, the blue light, the yellow, all the colors must be reaching my eyes. So let me first draw those. Okay, the blue light is a little hard to see. Let me just reduce the background. Okay, that's great. All right, now comes the next question. Where does that light come from? Where did that light come from? Well, we might guess that since rainbows are formed due to sunlight, maybe that's coming from the sunlight. But in what direction is sunlight? Sunlight is coming this way. So let's go ahead and draw that as well. Nice. Now with the rays drawn, we can start predicting what must be happening over here. You see, the incoming light is white, something happens, and then we have colors being thrown at me. So what phenomena must be happening over here? What must be happening to convert that white light into the colors towards me? Can you pause and think about this? You may have already learned this before. Okay, so the first thing I'm thinking about is how is this white light turning into colors? Have we seen this before? Yes, we have. We've seen this happening in Prism. When you throw a white light at the prism, we see colors happening, colors coming out. And why does that happen? Well, we saw before that white light itself is made of all the colors of the rainbow, all the 7 colors. They are traveling together, but when they go from one medium to another, different colors bend differently. Red bends the least, violet bends the most, and as a result, all the colors separate out. We gave a name to this phenomena, we call this dispersion. You can guess something maybe similar must be happening. Maybe the white light is separating out, giving us colors. So that's one thing that's happening over here. But that's not all, something else. You see, just like in the case of the prism, the light should have just traveled in the forward direction. The colors must have just traveled in the forward direction. But no, the colors are turning and coming back towards me. The colors seem to be bouncing off of something. Ooh, that means the colors are reflecting, right? So it's kind of like the colors are hitting and then get reflected back. So these are the two things that must be happening. Let's go ahead and write that down first. So the two things that must be happening over here is one, separation, which we call dispersion. Dispersion of light. That must be happening over here. And what else? After dispersion, after the colors got separated, they must be reflected back. So there must be reflection happening as well. So after dispersion, reflection must be happening. And with these two, we are getting our rainbow. Okay, but who's causing that? Who's making this dispersion and reflection happen? There are no prisms in the air. Any guesses who's doing that? Well, you might guess that is the raindrop. So the raindrops are taking the white light, separating them, and then reflecting them back to give us the rainbow. Isn't this amazing? Just like how scientists do, we worked backwards to figure out, or at least make a guess as to how rainbows are formed. But this might start raising more questions, more interesting questions. For example, if each raindrop is giving me colors. Why do I just see one single rainbow? Shouldn't each raindrops be giving me rainbows? It should be a complete mess of colors, right? Why do I see this nice pattern? Okay, interesting question. Now maybe to answer this, we need to dig a little bit deeper and see what's exactly happening inside those raindrops. So you know what? Let me get rid of this rainbow for now and zoom into this particular raindrop. So now let's see if we can figure out what happens inside this raindrop. All right, so here's the white light entering the raindrop. Let me draw that. There are a lot of rays of light. Let me just draw one ray of light that's entering my drop. Okay, here is the white light entering. What's gonna happen to that? Well, I want you to try and pause this video and see if you can draw this yourself. It's important because you already know the rules of reflection, refraction. You've already done ray diagrams before, so it'll be a great idea to pause and see if you can do this yourself. All right, hopefully you've tried. Let's zoom in and see what happens. We have white light. Let me zoom in even more. Zoom in even more. Okay. We have white light that is going from a rarer medium to denser medium. So it's going to, some part of the light will enter into the drop, it will refract, and some part of the light will reflect, okay? I don't care about the reflection, I'm worried about what happens inside the drop, so let's consider the refraction case. So to draw the refraction case, I need to first draw in normal. And how do we draw normals for curved surfaces? Just like in the case of mirrors, we'll draw it from the center of curvature over there. Here it'll be the center of this drop itself, right? And in fact, this is the reason why we consider the raindrops to be spherical. In reality, the raindrops are not exactly the shape, but we're approximating it so that it becomes easier for us to draw. Okay. So what happened to this white light? It's going from rarer to denser, so it's going to bend towards the normal. But remember, not all colors bend equally. Red bends the least. So here's my red bending towards the normal. It's going to bend a little bit, let's say. And then blue or violet, I'm just going to draw it as blue. It's easier to see. So violet or blue, that bends a little bit more. So I'm just going to make it bend a little bit more. What happens next? Now this is important because there are some misconceptions that exist over here. Well, what do you think happens? Well, it's a raindrop, which is transparent. That means the light will just exit. And that's true. In fact, most of this light will just exit the raindrop this way, and it will not reach our eyes in this direction. But some of that light will reflect. Like, I mean, right? In water, some light gets reflected and most of the light goes through. Same thing's gonna happen over here. Some of the light is gonna get reflected. Now, the misconception is a lot of people think, and even in some books it's written, that the light gets total internally reflected, meaning all the light gets reflected. That's not true, okay? I'm just saying that that's not true. Only some part of light gets reflected, just like usual. Like how usually water reflects some of the light, some part of the light gets reflected, and that's what I'm interested in. And so I'll not draw the light that goes out. So let me draw the light that is reflected. To do that, again, I have to draw normals, right? So let me draw one normal for blue, and let me draw one normal for red. And with this, now let's draw the reflected light. For red, here's the angle of incidence. So let's try to make the angle of reflection equal to the angle of incidence. Not like this, that's too small, this is too big. Somewhere over here, approximately. Let's do the same thing for blue. Notice for blue, the angle of incidence is a little smaller compared to that of red. I hope you can see that. And so we need to try and match that. It's not gonna be like this, it's not gonna be like this, somewhat like this. I always had troubles drawing this actually. And as you can see, drawing normals actually help. Okay, what happens next? Well, again, most of this light will exit the raindrop and some of the light will get reflected again. But now I'm no longer worried about the light that gets reflected. Let's draw the case of exiting. So again, I have to drop normals. So one normal for red, one normal for blue. And now we can draw the light that exits. So the blue light, it's going from denser to rarer, it bends away from the normal. And even the red light going from denser to rarer, it bends away from the normal. Let's quickly include the arrow marks. Great, with this hard work, we'll now be able to answer our question. So let me just zoom back out. And so we are seeing that each raindrop is gonna throw all the colors at me. Red at the bottom, blue at the top. But what's important is only one of that color is reaching my eye. In this particular case, notice that only the red from this raindrop is reaching my eye. And therefore, that raindrop is gonna look red to me. Let me draw that. This raindrop is gonna look only red to me. If somebody else was, say, standing on top of me and looking at that raindrop, maybe that would look blue to him or her. So for each person, that each raindrop is gonna look a specific color. Hopefully that makes sense. And also, one more important thing, you might be wondering, you might be saying, hey, you said that only a little bit of light reaches my eye because most of the light goes out, only a little bit of light is getting reflected, right? So then, is that little bit of light enough for me to see it? Absolutely not. A single raindrop is actually not enough, but there are many raindrops. So let me make a copy of this. What I'm trying to say is, let's take another raindrop, which is in the same line over here. That's also throwing red light at me. Another raindrop over here is also throwing the red light at me. So if you look at all the raindrops in this line, all the raindrops in that line, they're all throwing red light towards me. And all of that combined is powerful enough so that I can see the light. In fact, this is the reason why we need strong sunlight. Without the strong sunlight, the light will not be powerful enough and I won't be able to see rainbow. So you need powerful light, you need a lot of raindrops, only then you'll be able to get enough light to see red. Okay, what will I see for other raindrops, or how do I see other colors? Well, let's see. Let's say if I want to see violet, where should that raindrop be? Well, now I can just move this around. If I want violet or blue, notice that raindrop has to be a little bit below. So now if I look at this raindrop, or if I look at this angle, a little bit below, so let me just draw that again. See, this is my horizon. If I look a little bit above, I will see red. If I look a little bit below, I will see blue. So this raindrop looks blue and all the raindrops over here are going to look blue to me. And so what's important is that each raindrop doesn't give me a rainbow. They're all forming a part of the rainbow. And there'll be all the raindrops in between over here, and all these will give me other colors. What about the raindrops on top of this? They will not give me any color. Let me show you that. If there's a raindrop on top over here, none of the colors reach my eye. So they will not contribute to rainbows. If there's any raindrop below, again, none of those colors reach my eye. Again, they will not contribute to rainbows. And that's why the rainbows are only contributed by those specific raindrops which are forming over here, giving me that beautiful pattern. So here's one last question. How far is a rainbow? Well, at first we might think, well, it depends upon which water droplet the light is coming from, right? Because that's what gives us a rainbow. But we just learned that rainbows are not formed due to a single water droplet. They're formed due to lots and lots of drops. Drops which are far away and drops which are close to us. All of them combine to give us a single rainbow. So are rainbows far? No, they're not just formed by those drops. Are they close? No, they're not just formed by those drops. They're formed by a combination. So where's the rainbow? It's everywhere. Isn't that weird? I mean, clearly rainbows look like they're at a certain distance, but we just saw they're not. They are everywhere. Everywhere from close by to far, far away, everywhere is a rainbow. Amazing, right? It's not a thing. That's the thing. And rainbow is not a thing. It just looks like it's a thing, but it's not. It's not at a particular place. And of course, we didn't explore why the rainbow is a bow-shaped. That's something we'll explore in the future video, but that's it for this one. So let's summarize what we just learned. So let's recall some important things from the video. Can you first of all recall what are the two important phenomena that has to happen to our light in order for us to see rainbows? Secondly, can you draw a ray diagram showing refraction inside the raindrop? Then, using that ray diagram, can you explain the color sequence of the rainbow? Why is it that we always get red on the outside and the violet or the blue on the inside? And finally, can you explain maybe to your friends or to your family, how far are the rainbows? If you have troubles answering this question, don't worry, you can always go back and revisit the parts of the video.